As we've looked at combustion theory and on these engines and looked at that chemical reaction that's going on inside an engine, we've seen how things should happen in theory, but we've also seen that theory doesn't ever happen, and we end up with a lot of bad emissions coming out of our engines. And we've talked about why that is. And let's look at now, how do we clean this up? But first of all, who's told us that we got to clean this up? Well, obviously it's a societal decision that we can't keep pouring stuff into our atmosphere, and you know, that's not good. And actually the regulating body, at least in the U.S., is the EPA, the Environmental Protection Agency. And that group is the one that says, look, you've got to clean up your emissions. Now, this could be a really complicated discussion about what are the regulations and everything, because it varies by the size of vehicle, it varies by the application. So over-the-road trucks versus off-road farm vehicles, for instance, or construction vehicles are different. Big tractors and small tractors are different. But the bottom line is that there's been phased in regulations that dictate what is allowed to come out of an exhaust. So a manufacturer can't manufacture and sell a vehicle that produces more emissions than what the EPA will allow. So there's very tight restrictions on that. Again, we could talk a lot about that because they talk about the NOx's production that we just mentioned, the NOx gas. They talk about particulate matter, the carbon and soot, and that's a trade-off, and we'll come back to that again. And they really implemented over several years, several tiers of emissions control strategies. Tier 1, 2, 3, 4. We are now in Tier 4B and maybe looking at a Tier 5 that may come into effect in the next couple of years. So this has really happened over the last 10 to 15 years in our vehicle production. So tightening restrictions, change what is allowed to come out of that exhaust. So what are manufacturers doing to clean that up? So again, we got to go back and understand this trade-off. We talked about this before. The main trade-off is, hey, I really would like to have as high a combustion efficiency as possible. That means more power. The better that combustion is, the more pressure, the more temperature I get, the more I'm going to be pushing that piston down, the more power I get out of my engine. That's fantastic. So I really want high combustion temperatures for that reason. That means I'm not going to get as much smoke. We talked about how we could get smoke and carbon monoxide and hydrocarbons and everything when my temperatures are low. But when those temperatures are high, that's where I get that noxious gas stuff. That's bad. So what happens if I reduce those temperatures? Well, if I reduce the combustion temperature, that's going to reduce the NOx production, but it's going to be lower efficiency. It's not going to combust as well. I'm going to have more soot, maybe some hydrocarbons, more carbon monoxide. So what do I do? How do I trade this off? All right, so mitigation. What do the manufacturers do for this? Well, the first thing that really came into play as these EPA regulations started to dictate things with our vehicles was a vehicle engine and vehicle integrated control. So you saw a lot of computerized control of the engine. And we've kind of danced around that a little bit, but how we have sensors that are looking at the air, that the oxygen content of fuel that's coming in. We have sensors in the exhaust that tell us a little bit about the nature of the exhaust that's coming out of that engine. And we make adjustments just in timing, in fuel injection, air-fuel ratios, all that kind of stuff to try to control what's coming out of the engine. That's controlling that combustion process. And I've mentioned in the past that, hey, controlling that combustion process, we think of all this emission control as bad and it's going to be, a lot of problems. But really what that's done over the last several years has increased the efficiency of our vehicles. Our fuel efficiency has gone up in general in our vehicles. So that's kind of a good side effect of this, as manufacturers have been forced to come up with some of these new innovations. So again, injection timing, multiple injections, there's a lot of integration with the transmission or whatever load that engine is drawing. So the engine will talk to the transmission, and the transmission says, hey, here's what I've got going on. The engine says, okay, if I operate this way, I'm going to be more efficient. And so we change gears automatically, do some things in the transmission so that engine can be operating at a more efficient point. So those are some things that are going on just with engine control without doing anything to the exhaust. And that gets us part of the way. That'll help to clean up that exhaust some of the steps. So that was some of the first tiers of emissions tier regulations and how those were met. But then we have to really start looking at exhaust treatment. What do we do in the exhaust to treat that exhaust? And I'm going to, again, this is going to be a pretty general, broad look at these, but there are two fundamental technologies that are employed in most internal combustion engines. And these can be employed in some variation in both spark ignition and compression ignition engines. There's what we call EGR, which stands for exhaust gas recirculation, EGR, exhaust gas recirculation. Along with that, we might have in diesel engines, we might end up needing a diesel particulate filter, and I'll talk about that in a second. So that's the first technology. The second technology is what we call selective catalytic reduction, SCR, selective catalytic reduction. So automobiles have had catalytic converters on them for years. This is part of that technology, this selective catalytic reduction. It goes with that general class, that general goal of emissions treatment. So what are they? Let's break them down. First of all, let's start with exhaust gas recirculation. This one, when you look at it, seems absolutely stupid. Why would I do this? We talked in two-cycle engines how that's one of the reasons we have emissions is that we can't get all the exhaust gas out. We have the exhaust gas mixing with the intake air, and so we get these bad emissions. So now we're going to, on purpose, take some exhaust gas that comes out of the engine, recirculate it back into the intake. Oftentimes we'll do some cooling. We'll cool that off because this is hot gases. We'll cool it off before it goes back into the intake. Why would I do that? This is burnt gas. So there's no oxygen left in it. It's not going to burn with the fuel. So I'm putting stuff back in there that is not going to help with my combustion. That's right. That's exactly what we're doing. So we're putting some of that exhaust gas back in. It's not going to help with combustion. And what that is ultimately going to do is lower my combustion temperature. Oh, remember the combustion temperature, that high heat, was what caused my NOx gas emissions. That's what made those nitrogens atoms, those nitrogen molecules break up into atoms and combine with oxygens and come out with nitrogen and oxygen. So if I can lower that combustion temperature a little bit, I'm going to reduce those NOx productions. So that's the purpose of exhaust gas recirculation. Now, is that going to reduce power? Yeah, it's going to reduce power. That's part of what goes on. So we're not going to have as much power when we're pulling that back in, but we're lowering that combustion temperature and reducing the NOxes. Okay, so again, this is all a trade-off. So we have to think about, all right, where's the best operating point to achieve what I need to achieve? And a lot of times we will control, most of the engines will control how much of this exhaust gas is recirculated in an engine. Some of you may have had to replace an EGR valve on a vehicle because the EGR valve went bad. Your computer told you to change that. EGR, exhaust gas recirculation, that's what it is. So it's a valve that controls how much of that goes back through. So depending on how the engine operates, what it's doing, how hot it is, and so forth, they'll have temperature sensors in there that'll sense those temperatures, and they'll put some of that exhaust gas back to try to lower that combustion temperature. But again, the trade-off is now I'm going to probably increase some soot production as well. So I'm going to have a little less efficient of a combustion. So we talked about how all those carbons aren't going to find oxygens because there's not enough heat to keep them all mixing and running. So carbons might grab one oxygen, carbons might not grab any oxygen. It's going to come out as free carbon or as soot. I may have a little bit of hydrocarbon production in that as well. So we're trading off. So trying to find that balance point of what the best thing is for the exhaust. So this is one thing that we do to reduce, primarily to reduce the NOx production, the NOxes. Okay, exhaust gas recirculation will reduce that NOx production for us a little bit. Now, because that often increases soot in a lot of diesel engines, particularly, not so much in spark ignition engines, but in compression ignition engines, we're going to need a filter. So we've got all that carbon going out, so they literally will build a filter on the exhaust of the vehicle. So the exhaust has to go through a filter, and this is kind of a picture one. They're pretty complicated. It's not just like an air filter where you put it through and catches stuff, because you know, if a filter gets plugged up, I gotta have to change it or clean it or do something like that. So the way we handle this, the way a lot of manufacturers handle this, is we've got this filter, the exhaust goes through there, there's some ceramic walls in here that'll trap the carbon, and that carbon will get built up. And they have sensors in here, pressure sensors and everything, and they can sense when that thing is starting to get plugged up. And so then it will self-generate. So what they do is literally incinerate the carbon in this filter. So the engine will be operating fine, and all of a sudden in engines that have these, you'll hear something funny going on. The engine will start to sound funny, and the exhaust will get really, really hot. And literally what they're doing is putting fuel in here, burning fuel in here to literally get this extremely hot, you know, up to like combustion temperatures in the engine, and burn that, incinerate that carbon, so that it incinerates it, so that it doesn't go out as soot, and so they can clean it up like that. So it will regenerate. So and the engines, you know, computerized engines, they'll try to find a time when the vehicle is not, there's not a lot of power required, so they can do this incineration, but they'll regenerate. So there's a lot of funny things going on in exhaust. That's why sometimes on an engine, it'll be sitting there not doing anything, idle, and all of a sudden the engine will sound funny. It might even speed up a little bit, it might do something weird. It's like, what in the world? So the computer is probably regenerating and cleaning out this particulate filter in the engine. So that's how kind of the crazy things that's going on. So that, again, that is usually coupled, the diesel particulate filter is usually coupled with exhaust gas recirculation on a combustion ignition engine. Okay, so again, EGR is both compression and spark ignition engines. Now, the other strategy is what we call selective catalytic reduction. This is the catalytic converter on an automobile. In the diesel engines, we do it a little bit differently in there. So the idea is to both reduce the NOxes. So if we do have some of those NOx gases coming out, it's going to reduce them to N. So it's another chemical process. So we can spend more time looking at chemistry and reactions and all that kind of stuff. But basically, we take the engine exhaust, which might contain the NOxes, some carbon monoxide, maybe some hydrocarbons and particulate matter, and they go through this catalyst. So a catalyst is something that enhances a chemical reaction. So there's a certain catalyst on this in these catalytic converters that will make those, when those gases come in, it'll kind of make those NOxes break up a little bit, and hopefully the nitrogens will get back together by themselves and come out as free nitrogen. Those oxygen that they were holding are going to go find those carbon monoxides and the carbons, the hydrocarbons and things, and they're going to combine with those to what we really wanted from the beginning, the carbon dioxide and some waters. And again, maybe get rid of some of that particulate matter as well, but and reduce that. But again, it's a chemical process. Selective catalytic reduction, it's a catalyst that kind of excites or induces a chemical reaction to break up these NOxes. Okay, in vehicles, this is generally a passive device, so it just passes through. There's a honeycomb-looking filter in there that the exhaust has to go through that has all that catalyst on it that will take those NOxes out and reduce them down. In a lot of compression ignition engines and larger diesel engines, we actually add a separate liquid in there. So we add what is called a liquid called urea. It's literally fertilizer, urea fertilizer. It's, of course, a refined version of it that is filtered and everything and can be used in an engine. We call this a diesel exhaust fluid, DEF, diesel exhaust fluid. And there is actually brand names of DEF. There's several brands of this. But when you fill up your vehicle, a compression ignition vehicle, you put diesel in that vehicle. On the newer ones, you put the diesel in, and periodically you also have to fill up the diesel exhaust fluid. So there's some extra fluid that you got to put in. So the green cap generally is diesel on a vehicle. The blue cap is going to be this diesel exhaust fluid. And this requires a lot of unusual, more management and everything. There's going to be pumps and heaters and everything that's got to manage this fluid that gets injected into this catalytic converter to reduce these NOxes. Okay. Again, this is the diesel exhaust fluid is really only on compression ignition engines. You don't see that on automobiles, but you do see the catalytic reduction on automobiles. It's usually just a passive. It's just a filter that you run through. So all this stuff on here adds complexity, of course. And so some of the newer tractors, you'll notice when you shut them off before you walk away from the tractor, it's still making noise. You can hear things running and humming and clicking and whatever. And it is a lot of these pumps and everything that we're pumping that urea up into the filter. They're going to pull that urea back into the tank. There's got to be some heaters in there to keep it at the right temperature and stuff like that. So there's some energy that has to go in that to be able to control that exhaust, control the NOxes. Okay, so again, selective catalytic reduction, its primary purpose is to reduce the NOxes back to nitrogen, so I don't have those NOxes going in there. The exhaust gas recirculation, that was to lower combustion temperature to try to reduce those NOxes as well. Okay, so two things there that are going on. So summary, all right, what do we need to know from all this? There's a lot of stuff, and again, we can spend a lot of time really digging deep into these chemical processes and everything that's going on. What's critical from this? First of all, make sure you understand where emissions come from. That's why we went through that reaction equation, understanding what that theoretical reaction is and why things go wrong. It has to do with temperatures and heat. If I got a lot of heat, I'm going to create more noxious gases. If I don't have much heat, then I'm going to get more carbons and all that kind of stuff. So understanding where those things come from and some of the things, the basic things that we do to try to fix those problems. First of all, with just improving the combustion process with computer control the engines and injection timing and air fuel ratios and all that kind of stuff. But then also understanding the two major strategies for treating the exhaust gas recirculation, to recirculate that back in, lower combustion temperatures, to try to get rid of some of the NOxes, and then also the selective catalytic reduction as well. That's going to be the more of a chemical process that's going to reduce those NOxes even further and get rid of them. So that's it. That's the summary of what we need to understand for emissions control, how we control emissions in engines.